Welcome back to Tech is Strong with Shobit. In our last episode, we demystified pointers and saw that memory is just a giant array of mailboxes. Today, we are going to dive deeper into how those mailboxes are organized. You might have heard terms like stack overflow or memory leak. These are not just a random errors, they pointed to a fundamental architecture decision, the stack versus the heap. Understanding these two memory reasons is critical for writing robust, efficient, and secure software. Let's begin. Let us start with the stack. This is orderly, super efficient part of memory. It works like a stack of plates, last in, first out. Every time you call a function, a stack frame is pushed onto the stack. This frame holds the function's local variables and return addresses. When the function finishes, its stack's frame is popped off, and that memory is automatically freed. It is incredibly fast because the CPU always know exactly where is the top of the stack is. The downside, it is relatively small, fixed size, and if you put too many things on it, well, you will get a stack overflow. A stack overflow isn't just a website name. It is what happens when you try to push too much onto the stack. This is usually occurs when very deep recursion function call that never return, or when you declare a massive local array inside a function. A stack simply runs out of space and your program crashes. It is a computer screaming, I can't fit any more plate on this table. Now, let's look at the heap. This is the wild west of memory. It is much larger, more flexible, but requires you to be the boss. On the heap, you explicitly ask for memory when you need it using functions like malloc in C or new in C++. The system finds a chunk of available memory, give it to you, and return a pointer to its starting address. Crucially, you are also responsible for telling the system when you are done with that memory using free or delete. This gives you immense power. You can allocate memory that persists after a function return. But with a great power comes great responsibility. Heap pitfalls. Because if you forget to free memory on the heap, you get a memory leak. It is like renting a storage unit, putting stuff in it, and then losing the key and forgetting you ever rented it. The space is still yours, but you cannot access it, and no one else can use it. Over time, your program consumes more and more RAM until it eventually slows down or crashes. Other dangers including dangling pointers, a pointing to memory that is already being freed, or double free error, which can lead to unpredictable crashes or security vulnerabilities. So, when should you use the stack and when the heap? Use the stack for local variables with known sizes, data that only needs to exist for the duration of a function call. It is simpler, faster, and automatically managed. Use the heap for large data structure like objects or arrays whose size you don't know at compile time. Data that needs to persist beyond the function that created it. But remember, with the heap, you are the janitor. You allocate, you free. Understanding the stack and the heap is like gaining X-ray vision into your program's memory. It empowers you to write more efficient code, debug complex issues, and avoid frustrating crashes. If you found this helpful, smash that like button, drop a comment if you have a question or want to see a specific topic covered, and definitely subscribe so you do not miss the next deep dive. See you then.